Okay, this is going to be a quick overview of a project that I've been working on. And the project is based on the Beaglebone green. And this is from an example project provided by Texas Instruments. And it involves the PRUs. There are two PRUs on the Beaglebones. PRU stands for Programmable Real-Time Unit, and these are 32-bit RISC processors which are specifically designed to be able to handle real-time tasks, and they do not burden the Linux operating system, which is on the host ARM processor. So the project is to use the PRUs as a PID controller, which stands for Proportional Integral Derivative, and that is a feedback control system which is going to control the rotational speed of a DC motor, which we're looking at here. The DC motor has what's called a quadrature encoder, and it's going to be difficult to see here. It's on the lower end of the motor housing, and what this is, there's a circular magnet attached to the axle of the motor, and there are two Hall effect sensors which turn on and off, and these provide a rotational sensor encoding that is used as the primary control parameter in the feedback loop. And the outputs from the quadrature encoder are applied to two pins on header P9 of the Beaglebone green, and the PRUs actually have a PWM output configurable, and that is output from header P9. And going into the smaller breadboard in the middle there, that is a Texas Instruments driver IC, which takes the PWM waveform from the Beaglebone green and then uses a switching network that's connected to the, I think it's approximately 8 volts from the dual power supply on the left, and then applies that waveform to the motor, and therefore that's how it's able to control the speed of the motor. Okay, so both PRUs have firmwares. PRU 0 implements the PID controller, and then PRU 1 acts as the means of communication between the PRUs and the user space of the embedded Linux via the remote proc messaging functionality. So the system is running. It's currently set to 0, so nothing's happening. So we'll go over to my shell, and as usual, it's not going to focus, but I have this already set up. There's a nice user space program that allows you to issue commands to the PRU1, which is going, okay, now we can see it's focused. PRU MSG is the user space program. So what this is going to do is change the set point to 3000. So I'll hit enter, and we'll come back, and we'll see that the motor is indeed turning. I'm going to crank it up to 5000, and we should see the motor speed increase. Indeed it does. Now if I try to slow down the motor, the control loop tries to correct that error, and it really fights back and increases the torque of the motor. So the control loop is functioning, Now, another feature of the project is it's capable of serving data to a web page via the remote proc messaging and another user space. It's actually a shell program. So we'll go over here, and I'm going to start the server program, and it also prints some data to the command line. The 3 columns on the left is a timestamp, hour, minutes, seconds. The middle column is the output, which is actually the PWM, and in the middle is the encoder value, and then on the far right column is a set point. So the encoder value is actually the controlled parameter, and it's not exactly the set point, but it's pretty close. So now if I change my workspace over to a Chrome browser. Okay, so what the web page does, it graphs the PWM, RPM, and the set point. So what I'm going to do is I'm going to grab a hold of the motor again. Right now it's showing basically no error. So I'm grabbing the motor and I'm creating an error, and the loop is attempting to track this out. So this shows that the server and the PHP page, which communicates via the remote proc messenger back to the PRUs, actually works. There is another feature on the web page. It allows you to update the set point and the parameters of the PID controller. For some reason that doesn't work. It's based on PHP, and I don't know anything about PHP, so that is a subject for future investigation. So that's it. That's the system. It works well, and TI provided a large amount of help. There's multiple layers of technologies to get this thing to work. One other thing I would like to say is that I got this motor from eBay. It's about the same price as the motor that's recommended in the TI project documentation. I would much rather use this nicer motor with the already built-in encoder. It works beautifully with this project. So that's it, and I'm going to try to publish this to GitHub soon.